In section 11.6, we extend our trajectory interpolation to 7 degrees of freedom. We're going to be looking at the ARM 7 degree of freedom package and sub-packages like ARM 7 degree of freedom action server. Here we're going to interpolate joint angles up to 7 dimensions for the server, and in the client we're going to have an interactive input from the user to input individual joint angle commands. You can review the code below, and I will just run the demonstration here. So we open the terminal, and here at the top we start Gazebo. When the window opens, we can just drag it to the right, close this pane, and then ROS launch the robot with the position controller. So this is our 7 degree of freedom robot. Then we can start the trajectory action server, which begins to spin, waiting for the client commands. At this point in time, we can also start to see the topics available here for us that we have created. So there's for each of the joints, the 7 joints from 0 to 7, we have a place where we can command the joint angle, and then we have a place where we can check the state. We also have this general joint states topic where we can see each of the joint states. So down here, I'm going to call ROS topic echo -C. This flag clears the window every time. And then this -W3 sets the width of each number to 3 figures. This will make it easier to read the radians for the joint angle states. And then this is our topic, joint states. And this topic actually has different elements like position, velocity, acceleration. So here we just want to record the position. So you see basically like the shoulder 0 is at 1, and then the shoulder 1 is also at 0. This is elbow tilt, and then elbow pan, and then we get these at the wrist. So when we come back here to the action client, we can start that. Let me make this window a little bit larger. There's a little bug there in the code that makes or sends some goals to the arm and then tries to recover from that. So we will use these numbers down here as a reference to decide where to move. One thing to note on the terminal is that here's the interaction prompt for the user. Enter joint number 0 through 6, but because we have an independent thread like the callback, this is also printing to screen and then making it hard to read this entry. So sometimes you may want to separate these as separate nodes or have better visualization techniques so that the user can notice what's going on. So here we're going to enter a joint number, start with 0, and then enter an angle command. We could start something like this. Might be like a 10 degree move. Yep. Or we could move in the other direction. Alright. Then, well, let me see. Here it seems this topic is not updating properly. I'll have to look into that. Joint 1, we can also do a small change. I must have messed the angle here, so this might have been better at 0.2. Let's try that again. Move to 0.2. Nothing happened there. Oh, sorry, this is 1, 0.2, 1, 0.4, 1, 0.5. So you can see how the arm is moving through that space as we change joint angle 1. 0.6 radians. Okay. And then we can move to the next joint. So we can try something like 0.7 on this one. We get that elbow rotation. That was a big number. Let me go back to this topic and maybe change the width, see if that helps. Okay, so that 0.2 is coming up here. So try this again, 0.9. You can see that we're not quite there, so there's some error, steady state error in the controller. We could try 3 at 0.9. This is the elbow rotation or the pan. Again, the position controller is not doing a good job, or maybe I have overextended this value right here. This is the elbow tilt. Here we're because the controller is working at one joint angle at a time, we're getting this awkward behavior. In an ideal situation, we will be working with all joint angles at the same time. But as you can see, this is a way for us to interact with the robot 1 degree of freedom at the time. The client can be improved in many ways. We can use also Bezier curves, or potentially optimize trajectory planning using sensory information. There's planners that do real-time motion planning like Chomp or Stomp or iTomp. And here, for example, for Stomp, you can click on this links and see how we can include optimized motion planning that makes the most out of sensory information. So in conclusion, for this section, we're just extending trajectory messages to 7 degrees of freedom and seeing how each joint can be controlled individually. That's all for section 11.6. Thank you.